So this question here says the differences between an operating system for a computer and an operating system for an embedded system. What you've got to understand is that an operating system for a desktop machine is generally quite generic. It's almost like general purpose software, okay? An operating system, if I was to use it here in my classroom here, it's just a version of Windows, everybody can do it. But then what you've got to remember about embedded systems is embedded systems are designed to only carry out a specific job. So for example, an embedded system that you might have in your car is,
like,
I'll give you a hint, it tells you where to go.
Okay, like the GPS.
Yeah, the GPS, the sat-nav, okay? But that operating system will be limited in its instructions, so therefore it doesn't need as much memory, doesn't need as much processing power, because it will be a reduced instruction set.
Right.
Remember when we've talked about RISC and CISC, how you've got a complex instruction set? Our PCs are going to have a lot more instructions that they need to contend with, whereas they don't need as many instructions. So what this question is getting at here is the differences between the operating systems designed for a desktop computer and an operating system for an embedded. Well, a desktop computer needs to be able to support a huge amount of peripherals. You've got your mouse, your keyboard, printers, scanners, monitors, speakers, all sorts of things. An embedded system like sat-nav just has your screen popping up, all right? The other thing, desktop computers, you want to be able to customize them. You like to change your background, your wallpapers, think about your phones. I'm just going to run down this mark scheme here. Desktop is generally easier to upgrade. Desktop computers tend to run a wide range of hardware, which we just said already. Desktop computers are more likely to be networked, so again, they need more resources to be able to actually connect. You can get embedded systems that connect to, think about it, like you've got your sat-nav on your phone. You can connect that via Bluetooth to other people to communicate where you are and stuff. Whereas embedded systems don't tend to have, as we've said, it doesn't tend to use, embedded systems don't have as many instructions either, because they need to be able to live longer with the power. All right. Embedded systems are sometimes real-time. They need to respond quickly. They need to be able to cut out. Think about driverless cars. There are braking systems within them that are embedded systems, and they need to be able to just focus on that. If you can ever look up CAD/CAM in cars and how that all works, there's lots of embedded systems. Teslas, for example, have tons of embedded systems going on. So that's the mark scheme for that there. Right, what is the difference between an interactive operating system and a networking operating system? Okay, so this question here says a computer programmer is developing a theatre booking system and has decided to used OOP. The operating system installed on the computer is an interactive operating system. This has characteristics of both interactive and network. Explain what is meant by the terms interactive operating system and network. All right. Well, with an interactive operating system, it needs to be able to communicate directly. It needs to have a two-way communication. So, say for example, I put in, is this the seat that you want? It needs to be able to have you on the other end going, yes, confirm. So that's how an interactive, so it is quite similar to a networking one, but an interactive operating system is where the user and computer are directly communicating. The user will input and then wait for the output before they, so you going onto like a ticket website to buy something, you communicate, but you wait for the next thing before making your next input. A networking operating system redirects requests to remote resources. Have I got yeah, so it works on the network layer.
Okay.
And it redirects resources to remote locations. That's the key difference there. Let's have a look. Do you know what is meant by event-driven when designing system software?
Not entirely, but I'm guessing it's to do with like its operation is based on like when a certain action takes place.
Yeah, exactly. It's just like when you were programming with OOP and you have lots of different methods. But if I click one thing, if I click that button, the next event might be load up another form. That's what's meant by event driven. Or when there's an error, you get an event pop up that goes, no, that was wrong, please try again.
Yeah.
So our operating systems are often event driven when we use them.
Okay.
What is meant by software and hardware?
So hardware is all the like tangible, like physical parts of the computer.
Yep.
And software refers to programs which are run on the hardware.
Yes, spot on.
Okay.
So hardware are the physical components that make up the computer. Software are the programs or instructions that are executed or ran by the machine. Yeah.
Okay.
Okay. 3 types of management. We've gone over that. Similar question again. So you see they often throw that question in there. What you've got here is classification for different type of software used on the computer system and examples. Okay. So one thing that is not necessarily covered in a lot of depth when you're doing computer science, because we're doing all the mathematical stuff, is the different types of software. So we've got application software here. What's your understanding of application software?
So that's stuff that the user will directly interact with. Those are like software, like programs that the user will use for like something that they want to do.
Yep. So we talked a minute ago, all right, about different type of software available. So we know we've got general purpose.
So special purpose is one.
Yep. So that would be special. I'm writing it on here, but make sure you fill it out down here. So we've got special purpose, and the hint that gave it away there is a payroll system. It's specific to the role, okay? General purpose, what might I use as a general purpose piece of software?
So it could be like a word processor.
Good.
Or like sheets or something.
Yeah.
Okay.
Word processor. These will be like, for some people these will be the easier marks, but for the mathematical students, they actually are often the ones that trip people up. So then we've got system software, and there are different types of software. We've got our operating system, the library programs. Now let's have a look at what we've got here. Well, a compiler. What's that?
So it's like a translator.
Good. Yeah. Okay. And backup software. Utility. Can you remember other types of utilities?
Does disk defragmentation count?
Yeah, so you've got disk management, disk defrag. Don't forget compression software, that sort of thing. But yeah, machine.
Does utility include like antivirus and stuff, or not?
That would be system software, which yes, that would come under a utility. Yeah. Sorry, I'm like, yeah, obviously it is system software. What is the second generation? Machine code was the first. What was second?
Assembly?
Yes, it was assembly. And remember to go back over the bitwise operations. There's always an assembly question.
Okay.
All right. Going to pause this in a minute. A written program in second generation. So if first is machine code, second is assembly. It's been loading onto a computer in this form. It cannot be directly executed on this computer. What has to be done to make sure that it can be ran?
So you go and turn it into machine code.
How do I do that though? It begins with a T.
You would translate.
Yep.
And you would use an assembler for this one? Or is it a compiler?
An assembler.
Assembler, okay.
Yeah. Remember that a compiler is used when you are wanting to. So if you're using say for example an interpreter, and you want it to take that and run it on all the machines of the same, what's it called? The same architecture.
Right.
So like if I compiled a program on a PC here, I can then use that on every PC in the classroom because it's the same system architecture once I've compiled it. So that's the difference, all right? Whereas a translator translates it from assembly into machine code using an assembler. So I'm not going to write that in. why might a programmer finds that the executable, this is just what I've just said, the executable form of a program is transferred unaltered to another computer. This does not run and an error message is displayed. Why might this not be able to run on this machine?
The other computer doesn't have the same archetype, so it can't run the, like, it can't run that executable.
Yeah, because think about it, if one PC has got an AMD processor, but the other has got the Intel processor, the Intel processor is likely to have a different instruction set. Right. So when you try and use a compiled program that has been compiled to run using that machine code's not going to run on this,
right.
Yeah?
But then if you had the assembly code and then sent that over...
And then compiled it on that machine, yeah.
Okay,
Alright.
makes sense.
I'm going to stop recording that one.